Uh, okay, today we will continue with our host defenses mechanisms. Last time, if you remember, we talked about the non-specific immune response mechanisms, and if you remember, we talked about the skin and the mucous membranes and their role, and then we talked about the phagocytosis, the complement system. What really determines what those are here compared to what we are going to talk about today. Today we'll talk about the specific host defenses. When we talk about the non-specific host defenses, we talked about that there is no specificity that is involved. And also we talked about that there is no memory. So the first time, like the second time, like the third time, and so on. And so today we will be talking about the specific host defenses. So today we will talk about mechanisms that are going to have memory. So the immune mechanism is going to remember here the action that has happened the first time. And usually this is done by what we call memory cells. And today we will be talking about here the significance of that and the types of vaccines that are involved, and also the corona vaccinations that we are having right now. So here when we talk about the host defenses, and we talked about that last time about the main objectives of the non-specific immune response, and today we'll talk about the objectives of the specific immune response. So if you remember here in the non-specific immune response, what we talked about yesterday, that it is the second part of the equation, the naturally occurring mechanisms, and also very important to remember in the non-specific that there is no memory. And of course, all of that is the third line of defense, if you remember. We talked about that last time. So we finished the non-specific host mechanisms, and today we'll talk about the specific host defenses as part of the third line of defense. So remember that we are talking about specificity, and we are targeting one item at a time, and also the body remembers this action. So the second time is much, much faster than the first time, and the time frame is so short compared to the non-specific immune response. Also, the third line of defense here is usually mediated by antibodies, which they come from plasma cells, that comes usually from B cells, the what we call the humoral immune response, as well as the T cytotoxic cells, or the cell-mediated immune response. All they form the third line of defense. So the third line of defense include really the specific and the non-specific immune response. So these are the summaries of what we have talked about of last time, general innate or inborn that we are born with. This is the non-specific, and they differs among the species. So in animals, they are completely different from humans, for example, and the mechanical and physical barriers that we do have. This is non-specific. وحكينا last time عن chemical factors that are involved, like the low pH of the stomach, for example, the acids and the alkalis of the GI tract, and the normal flora here that are present and their antagonistic effect. And also we talked about the fever, if you remember, and how important that is, that our body temperature is closer to 37. It's not 37 specifically, check. It depends on our physiology related to that, but anything above 37, if you remember 0.7, that's 7.8, is called fever, which is a non-specific immune mechanism and defense. And also we talked about the inflammation here as a mechanism of non-specific defense of protection, and also the phagocytosis that is mediated by neutrophils and macrophages. So the first line of defense, non-specific, talked about that last time, the physical barriers, skin, again, and the mucous membranes, and of course, the cellular and the chemical factors that are produced. وحكينا عن السكن, it's dry, for example, this is non-specific. Mucus is just binding and the clearing of those infectious agents, and the antagonism, how they compete also for nutrients, and they antagonize here those invaders. Also talk about the second line of defense, and the first line اللي هو physical barriers. The second line حكينا على lactoferrins, for example حكينا على temperature وinterferons like alpha, beta, and gamma interferons. وحكينا last time, if you remember, about the complement system, and how the complement usually is a non-specific immune defense mechanism that ends up by destroying the cells and helps in the phagocytosis. So part of the complement is an opsonin component, and the acute phase proteins also are molecules that are secreted during the inflammation that have a protective mechanism, and the cytokines that are produced out of the cell, and we'll talk about some in the specific immune response today. Inflammation, non-specific mechanism, as well as the phagocytosis. وحكينا عنهم هذول last time, how they are called upon to come into the area, and also the phagocytic cells. You should know their types, like the neutrophils, and neutrophils are the most common phagocytic cells, macrophages, and the macrophages, they play a major role in the specific immune response, and we'll talk about them today. And when the microorganisms are phagocytosed, when they're called upon by chemotactic factors, then they are going to be the organisms are going to be destroyed, and then they are going to be expelled outside of the zone. In inflammation, here first we localize the infection, and we prevent the spread of the pathogens, and then we destroy those pathogens, and we detoxify the pathogens as well, and they aid in repair after that, which is the last step in the inflammation. And we said also many cells that are involved in the non-specific immune response, and the granulocytes, and حكينا neutrophils are the most common phagocytic cells, but we have others that are involved, like eosinophils that are involved with the parasites and the hypersensitivity reactions, and we'll talk about those later. Neutrophils, the most common phagocytic cells that are involved. The monocytes and macrophages, we'll talk about them today as very common cells in the specific and the non-specific cells that are involved. The eosinophils and the hypersensitivity reactions type 1, as well as in parasitic infections as well. And of course, here we talk about the lymphocytes, the B cells, and the T cells that are involved. I want you to remember that when the B cells are involved and activated, that change, those are the ones that are going to change to plasma cells and then to antibodies, and we call those the humoral immune response, while the lymphocytes, we have so many other types of these lymphocytes, and we'll talk about them in more details. We talked about the 4 steps in the phagocytosis. Chemotaxis, they have to be called upon to come into the area. They have to attach, then they have to ingest, and then they have to digest. That sometimes you could have deficits in the inflammation process. Sometimes chemotactic factors might not be produced, or here the digestion enzymes might not be also produced, and the patient gets or becomes immune compromised. حكينا كيف الفاجوسيتوسيس are going to take place, and sometimes how they some processes they could help in the phagocytosis, like in the complement, for example, and antibodies نسميناهم opsonins, and the process of helping in the phagocytosis process, we call it opsonization, if you remember. So the opsonins, they could be either antibodies or and this is the phagocytosis step. حكينا عنهم ذكروا last time, and how these organisms are going to be destroyed by the phagocytosis process, and the lysosomes that they contain the digesting enzymes, and any deficit in that, then the patient could be compromised. Some of the mechanisms by which organisms here they could escape here destruction by the phagocytes, like for example when they do have a capsule, is antiphagocytic. So encapsulated microorganisms, they resist the phagocytosis, and sometimes they could produce, زي ما حكينا last time, a substance called leukocytin that could destroy the white blood cells, and sometimes they could have waxes like Mycobacterium tuberculosis here that can interfere with the phagocytosis step. وحكينا that certain microorganisms like the rickettsias, legionellas, for example, the brucella, the coxiella, listeria, the salmonella, and the toxoplasma, for example, and the trypanosomes, for example, the leishmanias, or they could interfere with the phagocytosis process. The Ehrlichia, the tick-borne, the human monocytic ehrlichiosis, if you remember, or the human granulocytic ehrlichiosis. Here they could interfere with the phagocytosis. وحكينا هون the adverse the phagocytosis هاي كلياتها sometimes here patients how they could become immune compromised. For example, if the number of white blood cells decrease, we call that leukopenia, then the patient becomes immune compromised. Or for example, the motility of these cells could be affected, or the chemotactic factors might not be produced. Like for example, when patients are taking corticosteroids, they affect the motility of those phagocytic cells, and the patient becomes immune compromised. Or others, like for example, the Chidiac-Higashi syndrome, where the chemotactic factors here might not work in this here disease. Also the intracellular killing by phagocytosis, here it's going to be compromised, like in chronic granulomatous disease. So phagocytosis have no problem with that, but the killing process is going to be affected. وحكينا كمان في عنا other additional factors like for example if the patient is having malnutrition, especially low protein diet. Why we talked about those if you remember the additional factors that are involved, مثلا extreme age groups, مثلا in infants and old people, we consider those as immune compromised. Remember the drugs also, corticosteroids that are involved, sometimes some T and B cell defects. We'll talk about those later. Today we'll discuss in more details about the specific host defenses, and what are the mechanisms here that are involved, which is, we call it the science of immunology. So here when we talk about the science of immunology, we talk about the humoral immune response and the antibodies that are involved in protection, as well as the cell-mediated immunity, like T cytotoxic cells, natural killer cells, for example. So specificity and memory, I want you to remember that in the specific immune response. Specificity and memory. So when we talk about specificity, we are talking about here an antigen, an antigenic determinant, and a receptor. So both are present, and memory cells that remember that infection when it comes for the second time. So these are the main objectives that we are going to talk about. We'll talk about the here the antibodies, for example, the antigens, the B cells. What do we mean by an immune competent patient that has the ability, or its immune system is working fine? Immune compromised, that means that the immune system is not working properly. you have to differentiate between the humoral and the cellular immune response. Remember, humoral يعني antibody mediated. The cellular, we are talking about cells, specific cells here, like the T cytotoxic cells, for example, and so on. Distinguish between here the what do we mean by natural, passive, شو معنى active immune response and passive immune response. Active or usually is here required more of cells that are involved, I mean different cells that are involved, and we'll talk about those in more details, like thymus-dependent antigens that are involved. Thymus-independent antigen, what does that mean? What are the steps that are involved here in the processing of the thymus-dependent, for example, antigen, and the thymus-independent antigens? Will see the role of the macrophages and the major histocompatibility antigens that are involved. هاي كلها يعني terminology you are going to be so familiar with. Construct a diagram of a monomeric, for example, antibodies. نشوف كيف يعني what's a monomer, what does that mean? What's a dimer? And two molecules of antibodies, or polymeric, more than two, like the IgM antibody, for example. Identify and describe the 5 immunoglobulin classes. يعني بنسميهم احنا الايسوتايبس، الاي جي جي، IgM, IgD, and IgE antibodies. List the types of cells that are killed by the natural killer cells. هنشوف كيف cells that are killed by natural killer cells, like a tumor cells, for example, they are killed by the natural killer cells and the T cytotoxic cells, so they require a cell-mediated immunity. Name the 4 types of hypersensitivity reactions. And maybe tomorrow we'll talk more about hypersensitivity reaction, type 1, type 2, type 3, and type 4, and how they differ from each other. What do we mean by type 1, the anaphylactic type, type 2, the cytotoxic type, type 3, the immune complex, and type 4, the delayed type hypersensitivity reaction. Outline the steps involved in the allergic reactions. رح نحكي عنهم. And what is the mechanism of hypersensitivity reactions. And cite 6 examples of allergens. We see how people, they become allergic to certain types, and we talk about what we call the history of atopy, how certain people, they have the genetic susceptibility to develop type 1 hypersensitivity reaction, for example, and so on. And finally, list the 5 possible explanations for a positive tuberculosis. نحكي على delayed type hypersensitivity types of reaction. رح نحكي على tuberculosis is one example. So one of the tests that we do here to make a diagnosis of TB, or PPD testing, the purified protein derivative. So what does it mean if the PPD test is positive and the patient is having delayed type hypersensitivity reaction against the antigen of Mycobacterium tuberculosis? So here we talk about here the immune system, then we are talking about a humoral immune response, يعني antibody mediated, and the cell-mediated immunity. Here we are dealing with specific cells. So antibodies here are specificity, and memory, both of those. Humoral here always involves the production of antibodies. Antibodies play a major role in the humoral defense. So when we talk about humoral, we are talking about antibodies. And the cell-mediated, we are talking about cells that are T cytotoxic cells, for example, natural killer cells, and so on. And here the cell-mediated immunity involved here many different cell types, including macrophages. هنشوف كيف إنه macrophages they play a major role in this in the specific immune response. Although macrophages they are not specific, but when the cell-mediated immunity is activated, they will call upon macrophages to come into the area, and they will be activated, macrophages activating factors, and so on. راح نشوف role of what we call T helper in the production of cytokines and the cytotoxic cells. They produce a substance we call it perforin and cytolysin that destroys here the cells that are attacked. The cytotoxic T cells, delayed type hypersensitivity, Mycobacterium tuberculosis, natural killer cells and the killer cells, وراح نحكي على الgranulocytes roles in killing as well. طبعا هلا الرول of antibodies in the delayed type hypersensitivity reactions or in type 4 hypersensitivity reaction is so minimal. So the role of antibodies here is so minimal, and here we are talking about cells that usually they kill, for example, virally infected cells or tumor cells, and so on. So always when we talk about the delayed type hypersensitivity reactions, هنشوف إنه الantibodies they play a minor role, or maybe not at all a role in defense. All they are cells, like natural killer cells, for example, that usually kill virally infected cells or tumor cells. When we talk about here the acquired immunity, and we could have what we call an active or a passive here role. So when we talk about the active role, the active role, the active acquired, like for example here, when somebody is naturally infected, so the immunity that is going to develop against the pathogen is an active acquired. While for example, here when you take the antibodies through the umbilical cord, like babies, for example, and so on, this is a natural passive type of an antibody. While when you give a patient antibodies, which is a passive, this is here an artificial passive type, or in vaccines and antitoxins, for example, when you give a patient an antitoxin, this is an artificial type of passive immunity. So you should know all of these terminology. Here the active acquired immunity could be natural active or passive acquired immunity. The natural active زي ما حكينا when you are infected with an organism and you develop here resistance against. Natural active acquired immunity, immunity that is acquired in response to the entry of a live pathogens into the body. مثلا in response to an actual infection. Artificial active, here when we vaccinate. Artificial active acquired immunity, immunity that is acquired in response to vaccines. So you should be able to differentiate what does that mean when I say natural active or artificial active acquired immunity. Acquired يعني الأشياء المكتسبة. Could be natural or it could be artificial. Well, passive, the one that you get the products of the immune system, ونفس الشيء could be natural or could be artificial here. Passive, for example, here natural passive, this is the one that you get out of your mother through the umbilical cord. The artificial, when you give antibodies. Here, immunity that is acquired here when a person receives an antibodies, antitoxins and so on. This is artificial, contained in an anti-sera, for example, or gamma globulin. So when a patient takes a gamma globulin, this is an artificial passive. Artificial because we make it outside the body and then we give it ready-made passive immunity. So here the vaccinations is an acquired here passive type of an artificial when we make the vaccines, naturals when we do get infected with microorganisms. A child here receiving a vaccine, so this is an active process, but when the child takes antibodies, this is a passive. لما تعطي الorganism as such, this is an active, and the body responds into that. This is an active process. So the vaccines then will summarize of all what we have talked about here. It's an artificial induction of immunity, and we stimulate the body to produce an immune response. So artificial induction of immunity is what we mean by the vaccination. So when we vaccinate against corona, artificially we induce an immune response. And this process must have enough antigens, نعطي كمية كافية to produce the immune response for the protection, and the antigens that we give should come from all different types of strains. يعني كل ما كثرنا نوعية الانtigens, then the more that we are going to get an immune response. And very important here to put in consideration that the vaccine that we should be given must not have any side effects whatsoever. ما بصير نعطي a vaccine that has a side effects. نحكي على الكورونا vaccine لازم يكون safe, مش هيك؟ Safe and very effective. produces يعني antibodies, no side effects whatsoever. شو الفائدة إذا بنعطي مطعوم that has, for example, side effects? And we should not give a vaccine that cause a disease. ما بصير نعطي مطعوم اللي ممكن يعمل لنا مرض، مش هيك؟ So it has to be safe and it should be very, very effective. Always remember, the vaccines, they have to be safe and they have to stimulate our body to produce an immune response against the infectious agent that we want to protect humans from. Passive or humoral, humoral, it should produce antibodies, and cell-mediated, very important. Both they are going to produce memory cells. لما نحكي على memory cells، لما نحكي على الكورونا فور اكزامبل، الكورونا فاكسين اللي كلياتنا احنا اخذناه، مش هيك؟ ناخذ الفيرست دوز، مش هيك؟ والسكند دوز بنسميها احنا سكند دوز الانامنيستيك دوز، يعني انامنيزيا يعني the one that does not forget. amnesia معناها forget, anamnesia does not forget. فبنعطي الفيرست دوز initiation process and then we give the second dose اللي هي الانامنيستيك دوز. وطبعا هون مثلا بالكورونا بنعطي حتى كمان الثيرد دوز in order to stimulate the immune response and to increase the number of memory cells. بس راح نشوف انه احنا ما بنقدر نضلنا نعطي الفاكسينز all the time. نحكي first dose, second dose, third dose، ما بصير fourth dose و fifth dose وكل اسبوعين نعطيه and so on، لانه هذا is going to induce an immune suppression. ولا راح نشوف كيف في الهايبر sensitivity what are we going to do in order to minimize the immune response. لما واحد يكون عنده حساسية، يكون عنده مناعة زيادة. So what do we do in order to suppress the immune response? نعمل desensitization or hypo sensitization as we are going to see. نعطي frequent doses يمكن أسبوع مرتين and so on. So we see that our body is going to produce anti-idiotypic antibodies that are going to block the immune response. فتذكروا انه بالفاكسين نعطي initial dose and booster dose. ممكن نعطي more than one booster dose ولكن not that frequent. We have to put that in consideration. Otherwise we could suppress our immune system. تعطي تأثير عكسي. طبعا different types حكينا ان في عندنا احنا يا اما active vaccines او passive vaccines، مش هيك؟ الاكتيف vaccines احنا نعطي الانتيجين and we let our body produce the humoral immune response يعني antibodies and the cells that are involved in the immune response. أو passive immunity يعني already بنعطي the products of the immune system already made. بس بالactive immune response we produce memory. تذكروا memory يعني the body remembers. لأنه في الباسيف لما نعطي الاميونوجلوبولينز جاهزة and so on, we does not produce memory. So an active immune response is more efficient, more effective compared to an active. ولكن sometimes we could need the passive immune response خصوصا لما بدنا يعني products fast وتكون جاهزة already. فمثلا في الactive immune response some of the vaccines ممكن نعطي live vaccines. نسميهم احنا life attenuated vaccine. life attenuated يعني الانتيجين is weakened يعني مضاعفة. And so here our body is going to be exposed to antigens that will here simulate the natural infection. Well, ممكن نعطي attenuated viruses, attenuated bacteria, like the one that we use for vaccination against mycobacteria. It's an attenuated bacteria. The one that we use against poliomyelitis, for example, Sabin vaccine, it's a life attenuated. So those life attenuated vaccines, is extremely important to know that they should not be given to immune compromised patients. يعني ما بصير واحد مناعته ضعيفة نعطيه life attenuated vaccines، فنعطي killed vaccines أو inactivated vaccines. فإذا الفاكسينز يا إما life attenuated أو killed vaccines أو ممكن نعطي what we call subunit vaccines يعني pieces or part of the attachment proteins, for example, of the bacteria or virus that is causing here the problem. فمثلا here Neisseria gonorrhea مثلا we could give a subunit vaccine يعني part of the Neisseria gonorrhea. Neisseria, so it will prevent here the Neisseria gonorrhea from attaching itself into the host. So the pelli, for example, we could give part of the pelli of the bacteria that plays a role in adherence. So we will prevent the attachment of the microorganism into the mucous membranes, and we could protect. فلما نحكي على إذا الactive immunity, and it could be life attenuated vaccines in bacteria or in viruses or subunit vaccines. Attenuated مثلا bacterial vaccine BCG, Bacillus of Calmette and Gorin is a life attenuated vaccine. أو ممكن in the safest here to give inactivated vaccines. يعني نجيب الفيروس we heat it up, we kill it مثلا, أو sometimes you could inactivate it by chemicals. And so and then we give it to people, so it's so safe that it will never cause an infection. أو ممكن نعطي يعني toxins that are treated نسميها احنا toxoid inactivated bacterial مثلا vaccines say toxoids مثلا يعني part of a toxin tetanus toxoid and tetanus toxin is treated so it will lose its virulence but it keeps its antigenicity. The same thing here we applies for bacterial toxins or for viruses مثلا hepatitis B virus. This is inactivated virus, so we could for inactivated virus we could give it to people. So I want you to remember then the vaccines live attenuated or inactivated or toxins that are in deactivated toxins, toxoids. All of those are very efficient and active process of vaccinations. While في passive, we give the products of the immune system ready made. والفرق زي ما حكينا انه في الاكتف memory is going to be produced, and this is so important. While في الباسيف لا، انت بتعطي البرودكتس ready made, there is no memory cells. وفي issue sometimes some of the vaccines we call them conjugated vaccines, and vaccines that sometimes on their own then they might not induce an immune response, so we conjugate them with a protein carrier so they become immunogenic. So we could use those to stimulate an immune response. زي ما حكينا others اللي هو toxoids and toxins treated serious with toxoid. Also we could use that as of vaccine. وممكن نستخدم nucleic acid vaccines, يا اما DNA or RNA, it depends على الفيروسز. مثلا on DNA vaccines we could introduce a gene that here codes for the protein. هذا بنسميهم احنا DNA vaccines. وممكن RNA vaccines، يعني زي الفايزر vaccine تاع الكورونا، it's a messenger RNA. So we could give a messenger RNA vaccine that here goes into the ribosomes and make proteins شيك، وهدول البروتينز اللي هم for the attachment proteins of the virus. So here we talk about the vaccines. حكينا على الactive vaccines، حكينا proteins that are treated or nucleic acid vaccines، يا اما DNA or RNA، وهدول الجينز that will code for the attachment proteins. أو ممكن نعطي what we call autogenous vaccines، يعني the organism that is currently causing a problem، يعني مريض infected with Staphylococcus aureus from a boil, you could take that Staphylococcus aureus from that boil and make a vaccine out of it and then give it to the same patient. So we call that autogenous vaccines. So you should be able to differentiate those different types of vaccines: live attenuated, inactivated vaccines, subunit vaccines, gene vaccines that are made of genes that will code for the attachment proteins, or toxoids, yani toxins that are causing the disease that is inactivated, so they can here induce a humoral immune response. And the autogenous vaccine, the same organism that is causing the problem in the patient. Here we could make a vaccine out of that and then give it to the same patient. So again, this is a summary of what we have been talking about. يا اما بكون living زي ما حكينا or dead organisms زي ما حكينا subunits part of that vaccine بنسميها toxoids، يعني toxin that is treated غالبا lost its activity ولكن maintains its antigenicity. حكينا DNA vaccine نفس الجين اللي بيعمل attachment proteins and so on، هذا اللي طلعوا عليه مليون إشاعة وإشاعة. مش هيك احنا بالكورونا استخدموا الماسنجر RNA، ما استخدموش any DNA vaccine at all. Messenger RNA that here codes for the protein or attachment protein or spike protein. حكينا على ال conjugated vaccines that here the protein that is going to induce an immune response يعني on its own ما بيعمل immunity, ولكن when you conjugate it with a protein carrier مثلا it will help the immune response to make an antibodies conjugated vaccines. حكينا عن autogenous vaccines. Vaccines يعني هلا انت in pediatrics you should know all the different vaccines that the baby is going to take since birth, من اول ما ينولد الطفل وكيف ممكن نعطيه يعني الهيباتيتس بي مثلا فاكسين، وبعدين later على شهرين و4 شهور 6 شهور دي بي تي النظام الثلاثي. مش هيك كلهم هدول في الاطفال you should know all the different vaccines اللي لازم ياخذوهم humans يعني since birth all different phases of life. hepatitis مثلا hepatitis B vaccine, DPT diphtheria pertussis tetanus، وفي ال A اللي هي acellular لانه وجدوا بعض الفاكسينز يعني اذا كان complete cell could have more of side effects، فصاروا يعطوا ال AT acellular pertussis تاع السعال الديكي يعني، وهيموفيلس انفلونزا كذا تايب بي، هذا اللي كمان يعني بيعمل اوتايتس ميديا meningitis in children and so on، فهذول بعطوهم كمان بالاطفال. ذكروا يعني conjugated vaccines inactivated polio vaccines سميها IPV، الMMR يعني measles mumps rubella نعطيهم هذول بعد السنة الأولى الحصبة والحصبة الألمانية for example. الفاريسيلا vaccine، chicken pox، النيوموكوكال conjugated vaccines يعني streptococcus pneumoniae they were conjugated with a protein carrier بصير more immunogenic. hepatitis A virus كمان، والانفلونزا فاكسين. تذكروا الانفلونزا اللي احنا اخذناه الشهر الماضي، الانفلونزا مشكلته الانفلونزا فاكسين انه it keeps changes its antigenicity لانه it's a segmented genome، عشان هيك we have to keep giving that every year. بينما الكورونا for example it's linear، ممكن changes تصير because of يعني طفرة يعني mutation، so they could give يعني all different types of mutants. نحكوا على type that has مثلا 30 different variants، بعطوا 30 different variants in one shot، ولكن the genome of the corona for example is linear, so it changes that usually occurs is so minimal يعني compared to influenza. Influenza it changes is so high علشان هيك they have to give it every year. مثلا we don't give vaccine for the common cold. الكومن كولد اللي هو الرشح ما بنعطيه. ليش؟ لانه we have so many different serotypes that are associated with the common cold، فمش معقول يعني انه نعطي so many different serotypes of the common cold. ذكروا على الانفلونزا vaccination والانتيجينيك shift and drift وكيف it keeps changing its antigens، عشان هيك we have to give it every year. Very important. فإذا the problem with the common cold so many different serotypes، بينما الانفلونزا it keeps changing its antigens، عشان هيك we have to give it every year الانفلونزا فقط. بينما الكومن كولد لانهم they are so many والكومن كولد is so mild يعني ما حدا بيموت من الرشح شيء. بينما الانفلونزا people they could die as a sequel to that. الكورونا they could die. عشان هيك we have to vaccinate people. الانفلونزا والكورونا والأرزول كلها linear vaccines ما بتتغير زي ما انتم شايفين. يعني التغييرات تكون mutations that is can be so controlled easily. So how vaccines they work? طبعا by they produce antibody production. طبعا the most important thing to remember that they not just producing antibodies but they produce memory cells as well. While memory cells that they produce they can last for a longer periods of time, for years and years. فلما نحكي على antibody production بيحكوا على انه الكورونا مثلا vaccine الانتيبوديز of the corona مثلا it will last for 6 months and that's it. ولكن they don't talk about memory cells. Memory cells they last much longer than that. عشان هيك لما احنا when we vaccinate للكورونا ونعطي booster dose first to second booster we make so many different types of memory cells that are going to stay in our body for a longer period of time. وطبعا لما نحكي على antibodies that are produced their effect is going here when we give it. Antibodies that are produced they are going to bind into the attachment protein of the virus or toxin or bacteria and they prevent its action on cells. They act as opsonins and they help in the phagocytosis process and also they help in the complement activation. نحكي على يكون الفاكسين IgG and IgM antibodies. IgM to start with وبعدين IgG هدول they are complement fixing antibodies so they fix complement وبعطوا يعني specific immune response and non-specific immune response at the same time. هلا antigens or immunogens that we are using في vaccines. فلما نحكي على antigens يعني it's the substance that induces an immune response. ولما نحكي على thymus dependent antigens and thymus independent antigens. ولما نحكي على thymus dependent antigens those are the ones that the thymus gland uses after they are here attached to class 1 and class 2 major histocompatibility antigens and then they present it to T helper cells and then the T helper cells are going to produce the cytokines that will help in the specific immune response. So here those are involved with what we call the antigenic determinants. So the antigenic determinants, the specific parts, epitopes. Epitopes that they do have a receptor on the B cells as well as the T cells. نحكي على antigenic determinants. Those are the specific parts of an antigen that is going to be recognized by those immune cells. Certain types of substances, we call them haptens. Those substances on their own, they cannot induce an immune response. But when you hook them with a protein carrier, then they can induce an immune response against the carrier as well as the hapten at the same time. So here, when an antigen is, for example, exposed into a B cell. So the specific cells that we do have in our body اللي هم حكينا ال B cells or the T cells. Why they are specific? Because they do have receptors. يعني كل B cell عليها specific type of a receptor. If you do have the receptor in your body, then you will respond. And then you are going to produce a humoral immune response and then cell-mediated immunity. So the B cell, through its receptor, and the receptor here is a monomer of IgM antibody that binds into the B cell horn, then they stimulate the B cell to change into a plasma cell, and then the plasma cell will produce an antibodies, and at the same time they produce memory cells. هذا اللي انتو you have to remember. When we are exposed to an antigen, and we are exposed to an antigenic determinant, as you can see, and the B cell, through a receptor that is going to bind here into the antigenic determinant, will change into a plasma cell, and then antibodies are going to be produced. So here it's so important to remember that when we are exposed to an antigen, it's not just antibodies that are going to be produced, but also memory cells. And the memory cells are the ones that are going to last for a longer period of time. And those are the ones that occasionally we activate them. And we should not use the vaccine so frequently here. Otherwise, we could desensitize or suppress the immune response, as we are going to see later. So part of the humoral immune response is not just the antibodies that are going to be produced when we are exposed to an antigen, but also memory cells. And those memory cells are the ones that are going to stay in our body for a longer period of time. تذكروها هاي احنا لما نطعم وناخذ البوستر دوز بتاعت الكورونا، هلا اللي الحكومه طالبين منا كل واحد ياخذ الثيرد دوز. احنا هون is the idea is not just to get more antibodies. We will be getting more antibodies, but also the most important thing to remember that we are going to increase the number of memory cells in our body that are going to stay for a much, much longer time, and then we become immune for the corona for a longer period of time. Remember that. لما نحكي على the humoral immune response, not just antibodies that are going to be produced that will last for 6 months, but also for memory cells that are going to stay in our body for a longer period of time. وهدول they respond to an antigenic stimulation in a shorter period of time. يعني الوقت اللي باخدوه to respond لما الواحد to be exposed to them بيكون much shorter compared here when naturally we are exposed to the antigen. So it is so important to remember that here the antigens that we are going to be exposed to, we could be thymus dependent or what we call thymus independent antigens. So the thymus dependent antigens are going to bind to class 1 and class 2 major histocompatibility antigens, for example, that are going after being processed by a macrophage, antigen presenting cell. And when those antigen presenting cells present the antigen here to B cells, then more antibodies are going to be produced and more here memory cells. So I want you to remember that it depends on here what do we mean by thymus dependent and thymus independent. while the thymus independent, no macrophages are going to be involved in the process that are going to present those into the B cells. So here, the antibodies that are going to be produced in our body here are 5 classes, as you know: the IgG, IgM, IgA and IgD antibodies. ولازم تعرفوا مثلا كيف the IgA antibody are present in our body secretions, like in the saliva. We could have antibodies of the IgA type in the blood, in the mucus, in the colostrum, which is the first milk that is produced, in the lymph, for example, and in the blood plasma. كلهم the antibodies are going to be produced here beside the memory cells. So in our body fluids, we are going to have these different types of antibodies, and you should know the structure for each of those antibodies that are involved and their mechanism of action. So when we talk about the humoral immunity, humoral immune response, يعني the immunity that's going to lead to the production of antibodies. Remember that. So antibodies that are involved. So nature are antibodies, زي ما حكينا here, and we do have what we call a cross-reacting antibodies. What does that mean? وهي معلومة يعني you should know it. That sometimes an antibodies that are produced in our body in response to an antigen that did not stimulate their production. يعني ممكن يتكون in our bodies يعني antibodies نسميهم cross-reacting antibodies اللي هدول بيعطونا sometimes false positive results يعني في التست that were not responsible for their production. نسميهم cross-reacting antibodies about false positive results. وهدول another name for the antibodies نسميهم immunoglobulins. Immunoglobulins يعني they are responsible or production from the globulin part of the protein that is involved. Amount of antibodies, it depends on the nature of the antigen. The antigen is a protein, for example, or carbohydrates, or mixture of both. Glycoproteins, تعطينا the best type of antibodies. Then aside, whether intramuscular, IM, or IV, for example, or subcutaneous. So where did you get that antigen determines the amount and the type of antibodies that are involved. The number of times the patient exposed. And when you are exposed the first time, بنسميها primary immune response. When you are exposed the second time, بنسميه secondary immune response. بصير في activation to the memory cells and more antibodies that are involved. You have third مثلا times, the same thing. But we should not keep doing that زي ما حكينا because this is going to lead to suppression of an immune response. فإذا هدول حكينا immunoglobulins or the antibodies that are produced it depends on the amount of antigen that we are exposed to, with site, whether IM or IV, for example, or subcutaneous or cutaneous, for example. وحكينا كمان شو يعني thymus dependent and the thymus independent antigens, the involvement of the thymus glands exposure to T helper cells, and the T helper cells produce the cytokines that are going to modify or modulate the immune response. So you have to know what do we mean by a primary and secondary immune response. Primary first time, secondary second time البوستر dose. بعد 4 to 6 weeks of the first ناخذ السكند, so we will activate the memory cells to produce more of memory cells and more of antibodies that are involved. Other terminology, hypo and A gamma globulinemia. Hypo, and the amount of antibodies that are produced are minimal. A gamma globulinemia, يعني no antibodies are going to be produced. مثلا في genetic disease Bruton's A gamma globulinemia. Genetically, patients are not going to produce antibodies. هاي الانتيبوديز that are produced تعرفوا الفور chain model, two heavy chains and two light chains, as you can see. Two heavy, one, two of the same type, و two light chains. تعرفوا اللايت chain أخذتوا عنهم اللي هي الكابا and lambda for example, والheavy chain اللي هي الجاما مثلا النيو شيك يعني اللي بتعمل IgG or IgM and the rest of the immunoglobulin delta مثلا بتعمل IgD epsilon بتعمل IgE antibodies. فلما احكي على الكلاسز and subclasses of immunoglobulins has to do with the nature of the heavy chain. إذا كانت ألفا، إذا كان ألفا 1 ألفا 2 ألفا تعمل IgA antibody. إذا ألفا 1 IgA 1 antibody، مثلا ألفا 2 IgA 2 antibody and so on. فنحكي على الكلاسز and subclasses IgA 1 IgA 2 مثلا and so on في IgG and the others that are involved. فلما نحكي على الفور تشين موديل 2 heavy and 2 light هذا بنسميه مونومر. اذا يعني 1 unit of an immunoglobulin الفور تشين موديل بيكون 2 heavy and 2 light chains, وهدول بيكون فيهم كمان invaginations as you can see, وبيكون فيهم hinge يعني that keeps the antibody to move here from the light chain and the heavy chain, الhinge region زي المفصل. وطبعا it's a protein mainly and we have carbohydrates. الكربوهيدرات حوالي 2 to 4%, not more than that. ذكروا هاي الانتيجين binding site بيكون on the fab region يعني this is what we call the fab region, وهي بنسميها ال FC portion region. وهي ال FC بتكون has a receptor usually on cells, one heavy, one يعني the heavy, two heavy chains on heavy light اللي هي الانتيجين binding site. فالانتيجين binding بيكون يعني too heavy and too light. Hi, different types of antibodies that are involved. The first antibody that is produced, معلش بس دقيقة 1 minute بس 1 minute sorry. سوري على التأخير. إذا لما نحكي على ال immunoglobulins, we are talking about 5 different types. يمكن the predominant immunoglobulin اللي هو ال IgG. IgG antibodies. طبعا the first antibody that is produced اللي هو ال IgM. في عنا just one type of IgM زي ما انتم شايفين هون. it's a pentamer يعني في 5 monomers of IgM وفي joining here chain protein اسمها J chain أو joining that hooks the 5 monomers together. مثلا ال IgA antibodies في عندنا monomer 1 أو ممكن 2 dimer. في عندنا 2 types of the IgA, IgA1 IgA2 وهي في شايفين secretory component وفي joining region as well. فهم they are hooked together. وطبعا ال IgA antibody is usually present in body secretions and mucus membranes in the mouth. وغالبا اللي في the blood is usually not the secretory component. The secretory component or the S protein is usually present in order to protect the antibody from the body secretions, مثلا low pH في stomach for example and so on. فإذا لما نحكي على ال IgM it's a pentamer يعني 5 monomers of the classical prototype of an antibody يعني 2 heavy and 2 light chains. وفي عندنا الفاب region هاي اللي هون وهاي اسمها الفاب والإف سي portion. هاي الإف سي هاي البارت اسمها إف سي portion يعني the crystallizable fragment. والفاب يعني الانتيبودي or the antigen binding part. وهون في عندي 2 parts يعني one of the heavy and one of the light that is going to bind here to the antigen. فإذا في عندي أنا 5 units of that. طبعا كل واحدة is going to bind into 2 antigenic determinants. So the IgM has 10 binding sites. I mean, this is really very important. يعني هاي 1 unit of the pentamer. هاي يعني هون it is going to bind to an antigenic determinant وهون كمان another antigenic determinant. فكل واحدة is going to bind into 2. When we have 5 of these, so 10 binding sites are going to be present with the IgM. It has the highest molecular weight حوالي 900,000 Dalton. The first antibody to be produced لأنه في عنده a valency مسميها الvalency how many antigen binding sites valency of 10 لأنه هو 5 units وكل واحد بتمسك 2 so 10 units of binding. عشان هيك ال IgM antibody is the first antibody to be produced. لأنه its binding capability is so high compared to the other immunoglobulin. مثلا ال IgG في عندي it's a monomer يعني 1 وفي 2 binding sites بس. في مثلا ال IgE كمان monomer. ال IgD is present on the surface of cells and it helps in the receptor on the surface of B cells. ال A زي ما حكينا could be dimer يعني 2 or a monomer. Monomer يعني 1 unit, dimer 2. It has also a secretory component, S component. So the IgM has the most clotting or binding capability because of a valency of 10. It has 10 binding sites لأنه في 5 units كل واحدة binds into 2, so هنسميها valency of 10. It's the first antibody to be produced. Usually it's the best antibody to fix complement, and because it is so large, as you can see, a dimer or pentamer does not cross the placenta here into babies. The one that crosses the placenta is the IgG type. Well, IgG type, who are the only one that can cross the placenta, while the others, they are so large, so they cannot cross the placenta compared to the IgG type. The IgG, we need 2 antibodies to fix a complement. The most antitoxins, for example, are of the IgG type. عشان هيك, because the IgM is a pentamer, it's so large, the first antibody to be produced in order to make a diagnosis of congenital infections and so on, because we know that it does not cross the placenta to babies, you know, that infected in utero. We target the IgM, baby, نبحث على ال IgM antibody that's going to be produced. نكون ضامنين إنه it did not come from the mother into the baby. يعني the baby has produced that on his or her own to produce an antibody response. تذكروا إنه ال IgG is the one that crosses the placenta and going from the mother into the baby, والdimer IgA antibody is the antibody that's present in body secretions, saliva, for example, and does not fix complement. The one that fixes the complement is the IgM and the IgG. So IgG with the 2 antibodies to fix a complement, while the IgM is just one is enough to fix a complement. هاي كل الانتي بوديز احنا حكينا عنهم. هاي الاي جي اي انتي بوديز والاي جي D, the one that's present on the surface and helps in the function of the B cell receptor. ال IgE اللي هم سميه احنا reagenic antibody, the one that is involved with hypersensitivity type 1. نتذكروا IgA, the one that is present in body secretions. IgD, the one that's present on the surface of B cells and play a major role in the B cell receptor. IgE, اللي هو reagenic antibody, the one that is involved with the anaphylactic type or type 1 hypersensitivity types of reaction. So in babies, then we look for the IgM antibody because we are sure that it does not come from the mother into the baby. So the baby has synthesized that as a result of an acute type of an infection. The one that crosses the placenta is the IgG type. The IgG type. IgG and the IgM antibodies. You can see the molecular weight. كنت شوفوا كيف ال IgM حوالي 900,000 pentamer. It's so big, يعني compared to an IgG that crosses the placenta. فعندنا 4 types of the IgG. يعني IgG1, IgG2, IgG3 and IgG4. وهدول كلهم monomers يعني compared to the IgM which is a pentamer. هاي their effect, هاي interactions, prevention of antibodies usually they prevent the attachment of pathogenic organism and a pathogen coated with antibody prevented from attachment. تعرفوا attachment is the first and most important step in infection. So if the antibody prevents the attachment of the pathogen to the surface, then it will not cause an infection. ممكن يعمل clumping يعني clumping وهون it helps in the phagocytosis. Here antibodies link here antigens together بيعملوا clump here forming a clump that phagocytes can ingest يصيروا كبار هيك بتيجي الphagocytes and they will phagocytose. Neutralization of toxins يعني toxin يجي الantibody binds to the active component. So the active component, the toxin does not work. Antibodies bind to toxin molecules to prevent them from damaging the cell. بطل يعمل damage. Help with the phagocytosis. هتشوفوا كيف إنه الantibodies also بسميهم إحنا opsonins. They can help in the phagocytosis process. والactivation of complements ما حكينا two antibodies of the IgG type or one IgM can activate the complement. And when the complement is activated, could lead to cell damage, chemotaxis, and they will call upon those to come into the area. Activation of the natural killer cells also, so the antibodies also they can help in the cell-mediated immunity and the activation of the natural killer cells. They do have receptors for those natural killer cells respond to antibody here adhering to cell surface by attacking the cells. So part of the function of the natural killer cells is usually by antibodies, as we are going to see later. هاي شايفين هيك هاي هون الantibodies that are bound to the pathogen, they prevent attachment. هاي مثلا هون هاي الاتاتشمنت بروتين، فلما يمسك فيهم الانتيبودي they prevent الاتاتشمنت، او ممكن يعمل clumping هون a clumping of the antigen, so it will inactivate the antigen. هون بيعمل neutralization of the toxin, active component of the toxin, so when the antibody binds here the toxin no more working. Help with the phagocytosis. هون شايفين كيف help with the phagocytosis process antibodies as opsonization activation of complement, 2 IgGs or 1 IgM will help to activate the complement. Activation of the natural killer cell. Natural killer cells they need antibodies. فما شايفين إذا هون antibodies they have so many different functions in اللي بنسميهم احنا humoral immune response. Prevent the attachment زي ما حكينا، بيعمل clumping وبيعمل neutralization of toxins, so toxins no more working. help in the phagocytosis process. They activate complement حكينا هون والactivation of the natural killer cells. So where the immune response occur and where is it going to take place؟ كل هذا immune response where it's going to take place. غالبا تعرفوا راح نحكي احنا على لما نحكي على الاميون ريسبونس في عندنا برايمري lymphoid organs اللي هي الثايمس والبون مارو، وبعدين في عندي secondary lymphoid organs. Secondary lymphoid organs like for example lymph nodes, for example the spleen, tonsils, adenoids. This is where these reactions is going to take place. فعشان هيك when the secondary lymphoid organs reaction is going to take place over there بصير في lymphadenopathy. They will increase in size. Spleen مثلا increase splenomegaly. Tonsils enlarge مثلا. Adenoids they will enlarge. The same thing. Peyer's patches the same thing. Mucosa associated lymphoid tissue and the M cells. كلهم هدول here secondary lymphoid organs. This is where the lymphoid activity or the humoral immune response is going to take place. So processing of the antigen production of an antibodies. يعني first of all antigen has to be processed usually within a macrophage, and when antibodies are going to be produced يا اما في المacrophages، وبعدين T cells are going to be involved, specific cells that are involved. T cells will B cells, the B and T cells are going to cooperate. Lymphokines are going to be produced in order to activate the B cell to change into a plasma cell and then to antibodies and then into memory cells. حكينا على thymus dependent antigens with thymus independent antigens, while steps that are involved. First of all, the antigen has to be taken with a macrophage. The macrophage will process the antigen and going to be linked to class 1 and class 2 major histocompatibility antigen, and then it's going to be presented into the B and the T cells. So macrophages going to ingest then the antigen and processing will take place. Then they will add up a major histocompatibility molecule, and this is so important and for the presentation. وبعدين الانتيجين here processing cells, macrophages, special type of macrophages. A T helper role, when it gets activated, they produce lymphokines. With lymphokines, they play a major role in this process. T helper and the lymphokines that are going to be produced, a role of the lymphokines on B cells. The lymphokines that are going to be produced, they will act on the B cells. They will activate the B cells, changing them into a plasma cell and then producing the antibodies. So the last step is the formation of the plasma cell formation. وبعدين antibodies are going to be produced, and of course memory cells that will follow. So this process of antibody production has to be regulated, and the T helper cells usually they help in this regulation, and sometimes they could be suppressive, and they could activate and they could suppress the immune response. وفي عندي thymus independent antigens that they will not need processing. They produce only IgM antibodies, but they do not produce memory cells, thymus independent. No memory, وفقط one type of antibodies are going to be produced. وبعدين طبعا here when an antigen binds into an antibody, immune complexes are going to be formed. Well, we will talk about these immune complexes and how sometimes they could precipitate in tissues and they could damage tissues and help in the tissue damage, hypersensitivity types of reactions. Sometimes here we could make the antibodies, and when a plasma cell is producing an antibody, usually it produces one type of an antibody. كل الantibodies produced from that plasma cell have very similar properties. بنسميهم احنا الidiotype, for example, or the allotype or the isotype. يعني IgG يكون IgG, IgM or IgM, and so on. So all immunoglobulins produced from one type of a cell, كلهم they have the same properties. And those antibodies that they come from one plasma cell, بنسميهم احنا monoclonal antibodies, the ones that we could make them in the lab. يعني نجيب plasma cell, we could diffuse it with a myeloma cell, here because this cell it has an eternal type of living and doesn't die. It's a malignant cell, but continuously they keep producing those antibodies. So the monoclonal antibodies are antibodies that usually come from one type of a cell. They have all the same properties and the same types. Another name for those is hybridoma. يعني fused cell, myeloma cell with a plasma cell بنسميها hybridoma. يعني الميكانيزم of monoclonal antibodies first في عندي fusion properties between the plasma cell and the myeloma cells اللي بنسميها احنا الهيبردوما, and then we could grow those in the lab, and then they will produce antibodies that we keep growing those for a longer period of time. فالantibodies that are produced بيكونوا one type, and it's a continuous type of a factory that comes from one type of a cell that you can make the same type of an antibody for a longer period of time. Although the antibodies, you could use them for serology reagents, for neutralizing antibodies, and so on. And you could make use of those antibodies that you could make in the lab, where you have a permanent factory of immunoglobulins. That was the humoral immune response, the antibody production, humoral immune response, والmemory cells that will follow. وحكينا هنا كيف نعمل neutralization, يعني function of the antibodies, the complement يعني activations and so on. The other arm of the immune response بنسميها cell-mediated immunity, where sometimes you require cells to inactivate cells or to kill cells. Usually يعني when you have يعني intracellular infection, and you have viruses that are present within a cell, you require a cell-mediated immunity to kill and damage those virally infected cells. Sometimes you could need an interaction between cells and cytokines. And cytokines, here are the substances that are produced from the T helper cells, for example, are needed to activate those cells that are going to be needed for killing. Or some of these cytokines could activate the macrophages as well, and mainly the macrophages are the best beneficiary here cells out of the activation of the cell-mediated immunity. And usually those cytokines, they come from T helper cells. راح نحكي على T helper cells, T helper 1, T helper 2, and how those they could function in the activation and sometimes suppression of the immune response. And the T cytotoxic cells that will destroy virally infected cells and tumor cells as well. The T delayed type hypersensitivity cells and the natural killer cells that are involved in the type 4 hypersensitivity types of reactions. So the steps that are involved in the immune response, the role of the macrophages, يعني antigen taken by a macrophage and then processed and then here added up a class 1 or a class 2 major histocompatibility antigen. So macrophage, they ingest then the antigen and then they will present that here into into what we call antigen presenting cell, into the here B cells or other T cells. So their role here in the thymus dependent, here the antigen presentation is extremely important. T helper then roll through the cytokines that are going to be produced, and lymphokines, and then the activation process or the suppression process or the control mechanisms in the lymphokine production and the effect on the other cells. The final outcome in the cell-mediated immunity is the production of two substances. One, we call them perforin and then cytolysins. And the cytolysin and perforins, they make holes in the cell, and the cytolysin is going to destroy that particular cell in the cell-mediated immunity. We have also what we call the tumor necrosis factor that will help in the destruction process, the lymphotoxin, and the natural killer cells here. They have this cytotoxic factor that's going to destroy the virally infected cells or the tumor cell. Toxins produced here by the effector cells here causes here disruption of the DNA and the organelles. فإذا يعني الcells that are going to be destroyed here by destroying the genetic components of those cells. So نحكي على lymphotoxins for example and so on. هدول they are going to destroy the cells that are involved by destroying of the DNA component. So the significant role of the T helper cells then is by the production of what we call the lymphokines, and these lymphokines, they could activate the macrophages in the destruction and helping in the phagocytosis process, and then the activation of those killer cells to perform their function. Natural killer cells, and the antibody-dependent cellular cytotoxicity mechanisms, they are involved in this process in the production of the cytotoxins, you can call them, or here the destruction process by the production of the these lymphokines that are going to destroy the cells. So the cell lysis could be mediated by sometimes antibodies, and ADCC, antibody-dependent cellular cytotoxicity, and antibodies, they could play a major role in the function of the natural killer cells. I think I will stop here, and maybe next time we will be talking about the hypersensitivities and the hypersensitivity reaction, which is mediated by a specific immune response. Here, when we talk about the hypersensitivity reactions, we are talking about these immune mechanisms that we have talked about. They are exaggerated, that could lead here to destruction of cells and sometimes death to those patients. وراح نحكي على ال 4 different types of hypersensitivity reaction. So I will stop here, and if you have any questions, you can ask me for the time being, and I will leave this here for next time to نضاي لنا كمان محاضرة على immune response, so we will leave that into next time. So if you have any questions, I'm willing to answer. في أي سؤال؟ تفضلي.
الاي جي جي هم حكينا انه لانه بيكون وزنهم اقل اشي بيكونوا اكثر اشي بالسيرم.
ايش هو؟
الاي جي جي انتي بوديز لانهم بيكونوا انه اخف اشي فبنلاقيهم باكثر تركيز بالسيرم.
حكي عن الانتي بوديز؟ الانتي بوديز يعني غالبا في عندنا they could be in serum زي الاي جي جي والاي جي ام, some of the IgA antibodies هذول بيكونوا غالبا بالسيرم, ولكن some they could be present in other body secretions زي مثلا السلايفا. نحكي على السلايفا ممكن يكون في عندي IgA antibodies that are produced as well. فهو لما نحكي على الانتي بوديز يس بيكون في السيرم معظمهم, ولكن some other they could be present. نحكي على الملك مثلا, الفيرست ميلك بنسميه colostrum, very rich with antibodies. مثلا تعرفوا اول حليب تعطيه البقرة للكالف, مش هيك؟ اللي بيكون very rich with immunoglobulins مثلا. فلما نحكي على الحليب we could have يعني في البودي secretions يعني immunoglobulins of the IgA type.
اوكي دكتور كمان سؤال, هلا بالكروس رياكتنج انتي بوديز حكينا انه مثلا بيكون في انتي يعني هم اكثر من انتي بودي او يعني at least 2 antibodies that react to the same antigen.
هو لما احكي انا على cross reacting antibodies هم الانتيبوديز that are formed against an antigens that were not responsible for their production. يعني بيكون في similarities, very high similarities between those antibodies and the specific antibodies that are produced. ولكن there will be enough to induce an immune response and tissue damage sometimes. وهدول اللي مرات بعطونا false positive results. أنا لما أجي أفحص patient يعني to see if he مثلا produced antibodies, sometimes ممكن يعطيني cross reacting antibodies, يعني antibodies that are produced not in response to that specific antigen. يعني ممكن other antigens produced similar antibodies اللي عملوا هذا positive type of a test. فهم نسميهم احنا cross reacting antibodies، بعطوني positive test ولكن مش هم الانتيبوديز اللي produced يعني in response to my specific antigen.
شكرا دكتور.
ولا يهمك. في سؤال تاني؟ الكل فاهم وما في أي مشكلة؟
دكتور ممكن سؤال؟
تفضل.
دكتور كيف شغلة المونوكلونال انتيبودي ثيرابي كيف بنطلع الهايبريدوما؟ يعني شو البروسيس؟
احنا رايحين نحكي عن هدول يعني in more details. هي الفكرة يعني very simple. أول شيء هي الفكرة هاي طلعت سنة 83 يعني 1983 اللي اخترعوهم in the lab، ووجدوا إنه يعني if you fuse myeloma cells اللي هي malignant cells مع البلازما cell that is going to produce that antibody، بتعمل انت fused cell هيسموها هيبردوما. وهاي الهيبردوما يعني it has both the properties of antibody production و continuity. يعني الخلية هاي لأنه هي it's a malignant cell myeloma cell ف it will not die، فبتضلها عايشة for a longer period of time. فأنت حضرت مصنع من B cells اللي بلازما سيل تعطيني الانتي بودي that has continuity، رح تضلها موجودة for a longer period of time. بتضلها هاي البلازما سيل تعطيني الانتي بوديز اللي أنا طعمت الانيمال اجينست. فأنا مثلا بدي أعمل مونوكلونال انتي بوديز مثلا ل انتيجين اكس، فبجيب هذا الانتيجين اكس وبطعم ارنب مثلا او ماوس وماني many times عبين ما يصير so many memory cells that are involved. فصار في عندي انا هلا plasma cells that are involved، وهي البلازما cells are going to give me الانتيبوديز اللي هو الانتي اكس. فباخذ هدول البلازما سيلز وبعمل لهم فيوجن مع مايلوما سيلز بصير اسمها هيبردوما، وهي اللي بخبيها عندي، وهي بتكون هي المصنع اللي it keeps producing anti-X antibodies جاهزة for a longer period of time. فايمتى ما بدي الانتيبوديز هدول بنطلع هاي الهيبردوما وبنخليها تعملنا الانتيبوديز يعني.
يعني دكتور الانيمال انتيبوديز عادي بيشتغلوا بالهيومنز؟
لا هو ال هي هيومن بلازما سيل. انت هي هيومن بلازما سيل يو فيوز ات. انت بتستخدم بس الميالوما سيل هاي عشان الكونتينيوتي فقط. هي هيومن سيلز.
تمام، يعطيك العافيه دكتور.
ولا يهمك. في اي سؤال ثاني؟ ما في اي اسئله؟ تعرفين هو هذا يعني اليونت هاي اللي هي بتاعت الاميون ريسبونس اللي موجوده ب 265 يعني بتلخص كل الكورس اوف immunology that you are going to take يعني in details. يعني احنا رايحين ناخذ detailed immune mechanisms. تشوفوا كيف راح نحكي على الانتي بوديز يعني مره ثانيه in more details. راح نحكي على الكومبلمنت، راح نحكي على الهيومرال اميون ريسبونس، راح نحكي على السيل ميديتد اميونيتي as well. ف يعني هذا راح نرد نعيده مره ثانيه. فهذا this is a background. When you understand it so easily you can understand what we are going to talk about in the immunology course. انتوا لسه ما اخذتوا ولا immunology course؟
اخذنا دكتور بالصيف.
اخذتوا؟ طيب يعني المفروض هاي الاشياء كلها بتعرفوها مش هيك؟ طيب خلاص جريت، ممتاز.
يعني هاي زي ريفيجن.
طيب اكسلنت. في اي سؤال ثاني؟ طيب يعني إذا ما في أي سؤال تاني يعني next time we are going to meet and we'll talk about the hypersensitivity what's left يعني of that chapter. هاي chapter اللي هي chapter 16 I think يعني in your book. اوكي الله يعطيكم العافيه ونشوفكم معناته next time.
يعطيك العافية.
يعطيك
اهلا
العافية.
بك اهلا يا هلا بكم اهلين.